Dear students, today we consider exercise 6.2 problem number 6 triangles NCERT book class 10. So the problem given in figure 6.21 A, B and C are points on OP, OQ and OR respectively such that AB parallel PQ, AC parallel PR, show that BC parallel QR. So given this is a ABC, these are the points on OP, OQ and OR. These are the points ABC, and also given AB parallel PQ and AC parallel PR. Now we have to show BC parallel QR. This is nothing. So this is we have to prove. So solution, from so first we write given AB parallel PQ and AC parallel PR to show BC parallel QR. This is we have to show. So from triangle OAQ, this is the triangle OAQ. We have AB parallel PQ, AB parallel PQ, this and this parallel. Then by basic proportionality theorem we get OA by AP, OB by OQ. This, therefore, by basic proportionality theorem, we have what we have OA by AP equal to OB by BQ. This is number 1 we get. So this side parallel to this, so by basic proportionality theorem this by this equal to this by this. Again from triangle OPR, from triangle OPR we have, so what we have, AC parallel PR, AC parallel PR. Therefore by basic proportionality theorem we have, by basic proportionality theorem we have, so this side parallel to this, so this by this equal to this by this. So we have what we have, OA by AP equal to OC by CR. This is number 2 we get. This is 2. Now we get these two equations from 1 and 2. Equation number 1 and 2 we have. So in one, this left hand side OA by AP, here also 2 also OA by AP. Left hand side equal, then we can write right hand side also equal. So we get OB by BQ equal to OC by CR. So left hand side equal, then we can write right hand side also equal. So we get this one, OB by BQ, OC by CR. Again, now from triangle OQR we have, from triangle OQR we have OB by BQ and OC by CR. We have OB by BQ, OC by CR. We can write this is number 3 also. So from 3 or using 3 or proof above. This is from triangle OQR. So what we get, OB by BQ, OB by BQ equal to OC by CR. So we get this by this by this equal to this by this. So this is nothing but our converse of basic proportional theorem. Therefore, if this by this equal to this by this, then we can write BC parallel QR. This implies from this we have this, therefore BC parallel QR by basic converse of basic proportionality theorem. By converse of basic proportionality theorem, if this by this equal to this by this, then obviously these two are parallel, and this is our proof. BC parallel QR already we get, hence proof. This is the proof. We have to show this short, and this is our total proof. Consider problem number 7. Problem number 7 given using theorem 6.1. This is given in example. Prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. So bisect the third side. So prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. So first we consider ABC is a triangle. D is the midpoint of AB. Now we have to prove E is also the midpoint of AC. DE parallel BC. Now proof. Solution. Given a triangle ABC in which D is the midpoint of AB and DE parallel BC. To prove E is the midpoint of AC. To prove E is the midpoint. Given a triangle ABC in which D is the midpoint of AB and DE parallel BC, to prove E is the midpoint of AC. Now proof. Proof, since DE parallel BC, since DE parallel BC, therefore we get AD by DB equal to AE by EC. So if these two sides are parallel, then this by this equal to this by this, by basic proportionality theorem. By basic proportionality theorem we get this by this. Since D is the midpoint of AB, D is the midpoint of AB, therefore what we get, AD equal to DB. D is the midpoint of AB, that means this length and this length are equal. So this implies AD by DB equal to 1. If we divide both sides by this, we get 1. And this is number 1 we consider. Now 1 implies, in 1 AD by DB we putting 1 equal to AE by EC, or we can write this is AE by EC equal to 1, or AE equal to EC. AE equal to EC means E is the midpoint of AC. This implies E is the midpoint of AC. We have to prove this. Prove that a line drawn through the midpoint of one side of triangle parallel to another side bisect the third side. That means this one bisect this. That means E is the midpoint of AC. Therefore, so ultimately DE bisect AC. E is the midpoint of AC. So I consider problem number 8. This is very easy. Using theorem 6.2, this one given in textbook in example. Prove that the line joining the midpoints of any two sides of a triangle is parallel to third side. So we consider ABC is a triangle, D is the midpoint of AB, E is the midpoint of AC. Then we have to prove DE parallel BC. Very easy, very nice theorem problem. Now solution. So solution is start given a triangle ABC in which D and E are the midpoints of AB and AC respectively, in which D and E are the midpoints of AB and AC respectively. We can write of side AB, sides AB and AC respectively. this one. Now DE is this, respectively DE is the line, DE is the line joining D and E, joining D and E. So DE is the line joining D and E. To prove DE parallel BC, we have to prove DE of a triangle is parallel to side. So this one parallel this. Now proof is start. In proof, since D is the midpoint of AB, since D is the midpoint of AB, therefore we get AD equal to DB. Because this is the midpoint, means this length and this length equal. Now if we divide this side, then AD by DB equal to 1. This is number 1. Again, E is the midpoint of AC, therefore we get AE equal to EC. If this is the midpoint, then this length and this length are equal. Now we can write AE equal to EC. This implies AE by EC, this equal to 1. This is number 2 we consider. So if we divide both sides by EC, then this will be 1 and we get 2. In 1 and 2, from 1 and 2 we have, from 1 and 2 we have, what we have, this equal to 1, this equal to 1. That means right hand side equal means left hand side also equal. Then we have AD by DB equal to AE by EC. So this will be equal, because in right hand side this equal to 1, this one equal to 1. So right hand side equal means left hand side also equal. So we get this. So in case of triangle ABC, if we have this by this equal this by this, so from triangle ABC we have AD by DB equal to AE by EC. AD by DB equal to AE by EC, and this implies DE parallel BC by converse of basic proportionality theorem. By converse of basic proportionality theorem, if this by this equal to this by this, then these two sides must be parallel, and this is we have to prove. Hence proof. And this is the proof. So dear students, I think this problem solution is very easy. If you are feeling easy, then please like this video, subscribe my channel and click the bell icon. If no, if these are not easy, then no need to subscribe. If easy, you are feeling easy, this is very simple, then please subscribe my channel and like this video and click the bell icon. Thank you.